Good day, everyone. I'm Srini Ramani. I wanted to share with you all our learnings from our machine learning and AI projects we have been executing at Oracle and all the product management intricacies we have been through while doing this. And as you know, Oracle builds products that last 40 years or more, and no one other than Oracle has been able to build enterprise class products that really last and last. And customers definitely love them, and they're all the enterprise customers, almost everyone. So, so a little bit about myself. So I have been a software developer. I have more than 23 years of experience working in different software companies. I basically started off my career in GE Medical Systems, and I was working on magnetic resonance imaging, and that has come a long way now. So if I imagine what we had done 20 years ago in MRI, we were able to capture images, but we had no deep learning, no AI. So I'm really intrigued as to what we could do to such a system right now to help people handle diagnostic imaging so much better. And right now I've been into software development and then making different interesting and exciting products. I've been in Oracle for more than 14 years. Prior to that, I was at VMware, and before VMware on Computer Associates, and before that in HP. So I've worked on virtualization, the cloud computing, and now AI and machine learning. And I've also been an entrepreneur, built my own startup from scratch and grew it, and that worked on marketplaces. So that was another interesting journey for sharing another day. So let's get down to AI. So every customer, so the reason we build AI products is because all customers demand AI. All of you are familiar with Netflix. You love their recommendations. That then the virtual assistants, route prediction from Uber, so you can pick up your transport, video surveillance. You may not like it, but it can protect you. Chatbots, fraud detection, financial trading, healthcare, and self-driving cars. That's just the tip of the iceberg. So all of us as product managers will be building more AI products. And I wanted to share with you our experience on doing this. So basically, AI is reshaping every industry and job function, right from the customer experience, marketing, support, HR, you name it, it's changing it. So now our goal as product people is to bring our products to the masses and manage product development so that we can build products customers love. So basically, these are the statistics on AI. Is basically like by 2020, AI will penetrate about 87% of most enterprises, and it's going to contribute about 13 trillion to the economy as per McKinsey. Now, applying AI to the enterprise, that's quite a challenge because the traditional enterprise, you had fixed processes, intensive human interactions, and manual monitoring. All of a sudden, if machines ran the enterprise, what do you think would happen? And that's where we're trying to see what products to build and how to get all the exciting feature set that AI has into an enterprise, and doing that legally and safely. So the key thing that AI brings is, adaptive process, augmented experience, and autonomous operations. Now, the current state of ML and AI in business, with an adoption rate of only about 18%, but that means there's a lot of potential and so much more to go. The challenges are tremendous. AI is like right now, we have kind of a narrow short-term focus on individual ML projects. And each project is probably done in its own silos. They don't necessarily work all together. At Oracle, being an enterprise company which makes all-in-one solutions, we think of AI as how you can build it so that each integration brings together the whole organization and makes it much more efficient. So basically, right now the organizations are now segregated and disconnected. There's also cultural misalignment between development, maintenance, operation, services, and it's not really geared towards problem solving of multi-tenant SaaS applications. And then there's not that many AI or ML engineers to help or rapidly adopt these technologies. So a successful ML solution is like a joint effort of multiple product teams and organizations, along with participation from the customers, who are actually the beneficiaries of all the AI and ML that we can build. So, the approach to scale is basically like, what we have taken. So basically, we have built this core model. So first comes all these ideas. So our engineers and data scientists around everybody, right, starting with the Google people or Amazon, they build all these ideas, like all these imaging, VR, AR, and there's numerous research on that field. So we start with that, understand the capability of what these systems are and can be done. The next is understanding, planning and preparing how all of this technology can be put to use, and then building models for different financial problems. And then once the problems are adequately good for production, then it goes into production, consumption, and feedback. So we've developed a spoken hub model. So basically, we have integration of all the aggregate parts that are developed separately by different entities and different organizations, so that we can deliver a single unified AI solution. So as you guys know, AI or ML works best in a cloud-specific environment, because with a cloud you have unlimited processing power. The data is also available on a unified fashion and shared across different processing entities, and all this makes AI work better. So the first step in having an AI-specific processing in the enterprise would be to move to either a hybrid cloud, a private cloud, or a protected cloud. And then the next part is to build out the machine learning pipeline. So what that would involve is, like, business starts with the business consultants, approaching customers, identifying what are the most important problems they would like to solve. And since these consultants are already trained on how AI and ML will be put to use, they can advise these customers on problems that they should pick up one at a time, or as few as possible initially, to get familiar with how AI could be used in their enterprise. And the next part would be, put our R&D team to that problem to come up with a very good solution. And that's where we as product managers start getting involved. We understand what problems are there for customers, the priority of those problems, the ROI or that's possible. And then engineers, put together the solution, and we kind of productize that, and it gets deployed. But the key thing about ML is continuous learning. That's very different from other software. So once you deploy the old style software, it just sticks, the rules are the same, the performance doesn't quite change. With AI or ML, since it continuously learns, it could either work better, or in some cases it could even work worse. So we have to have lots of measures in the product to identify both new problems that AI creates, as well as how the systems are working, and benchmark it against traditional technologies, so that it is at no circumstance worse than, say, a statistical process or statistical results that are obtained by in a traditional fashion. So this is a pretty elaborate process we have built, and I can share that data with you. So what are the kinds of projects in an ERP that we have usually picked that customers think should help them the most? Is most of it is based upon commercial intelligence, inventory management, order management, prediction of raw, so how the business can predict different things, financial parameters, based on all the time series data they've already accumulated over time. Now, we have learned a lot of things so far along the way. So we have reimagined the end-to-end process. So it's not just, we cannot just lift and shift AI into the traditional enterprise. It kind of works, but then it's done in isolation and can cause sometimes more harm than good. So the product development process has to take into account the entire life cycle of the current products, where AI and ML is being deployed, and the implications of that. And then other part is we try to ruthlessly simplify AI, because it has to be such that anyone and everyone could use this technology with no AI training. It has to be just work exactly the same as the old and replace the new. That's the first key important requirement. And then we always design with the user in mind as to how they use the system and how to be sensitive to their emotional needs, so that we don't bring up data that they don't like. At the same time, it's culturally sensitive as well. And then we have very good established success criteria, OKR, and in consultation with customers, identify parameters that would clearly show why this system works better and what the goals are, and also identify if things are not going right, because if data changes, the algorithms can not work the same. So that's a risk that AI brings in. So there's always a need to benchmark against traditional systems. And then we nail this experience of every success we get and continuously magnify that and bring it back. So the other part is most of this AI, the advantage of running these in the cloud is that it's continuous updates. So development now is a CI/CD process, continuous innovation, continuous integration, and continuous development. And the other part is data migration. So AI depends on data for all its actions. Where this data resides has lots of legal, political, and organizational impact. And we carefully document and work with customers and their requirements to make sure we are in full compliance with all their needs. There are also some very unique problems that AI brings. There's no generalized solution. AI products could work very well in certain circumstances, but be disastrous in others. So it's very important to inform customers and keep a close tab to make sure that there are sufficient checkpoints in play to handle that. And then we have discovered in working with customers that there's a strong need for auto machine learning. So it kind of does its experiments automatically, detects what could be the best possible algorithm to use, and understand the reasoning behind that, and then give the user the minimum intervention. So things running in AutoML mode with all known possible algorithmic combinations is now almost a customer necessity. That's what we have heard from our customers. And the next bigger problem is a lack of labeled data, and that's something we have had to work with on all our AI product projects, and we have had lots of solutions we worked through on that. The other part is wide range of algorithms and the wide results different algorithms provide under different circumstances. And then the other part, customers really don't know much about AI. The vast majority, at least 85% of customers, are very wary or scared or just not technically capable. So we have to deal with that um, in terms of how we build our products to ensure it is compliant with their usage and knowledge base. And technology changes rapidly. So the hardware, software, algorithms move pretty rapidly. And there's also legal aspects. And defining product performance, enterprise use cases is an ongoing challenge, but it's the opportunity too. Because as AI can do more, we can do more with our products and keep enhancing that. So here are a few ways we handle the data problem, which is the number one problem for most of AI. So we used anonymous data that's available from different public sources free of cost. We use census data for most of the business things, and we have data of that for more than 300, 350 years, all the corporate filings. So we could use that data for much of the business prediction. There's also new things we could generate. For example, we created synthetic data generation programs, and then we also purchased data from third parties to help for the newer technologies. We also use transfer learning to learn from pre-existing data sets and apply that to newer kinds of data. These things are all experiments, and we have an intense process of experimentation to learn, innovate, and grow across the ecosystem. And we have developed a number of patented new data efficient algorithms so that very little data can also help us predict reasonable outcomes. And we do continuously have error tracking and learning. So for example, virtual reality is now big because with both Amazon and Facebook getting into that, they want to be able to read a human and take inputs as a human computer interface. And that's what the promise of AI is. It helps augment human intelligence, enhance natural human experiences, predict outcomes, accelerate decision making. And to lead the successful AI strategy, we have focused on identifying valid business problems which we have adequate data to prove that it would make a difference in employing AI. We have improved the data collection mechanisms of all modules so that the data collected can be very efficiently used. Then data preparation and modeling. See, almost 95% of the software product effort is to deal with how the data is handled. And just 5% of the effort is built on the algorithms. And with AutoML being part of almost every product line, we want to systemize and maximize the usage of the scarce AI/ML resources. So the other challenges on enterprise AI is the fragmented use case. There's so many data silos which limit effectiveness, the incompatible systems, and then the multiple platforms. The other area of weakness is technology and infrastructure. Some of it is in the Stone Age. Model management, specialized hardware, scalability are still big issues in many environments. And the more important problem is a lack of skills at this point of time. So AI is more advanced. It can do a lot more, and now people are learning, and that domain gap is going to be bridged, and that's where opportunity for everyone. So the goals we had were ready to go products, which were identify them and get them built, and then we wanted AI to work for our customer so that it's self-driving, self-securing, and self-repairing. The reasons we picked our own autonomous database is AI can help eliminate human error, and that's very important for everybody. Then data management is another big area where AI can autonomously help prevent data breaches, improve security. We also created lots of applications to create and leverage smart data. So the next set of things is that we are doing is is an end-to-end platform and that is enterprise level challenge, and for which significant resources and effort is being employed. So, you know, so we basically, the other challenge of AI product management is integration of data engineers, data scientists, business analysts, data controllers, and data software that already exists. Most of the legacy software that has not been built with AI in mind, a lot of that actually runs most of the businesses today. And there has to be a way that nobody is going to replace all of it, because there's significant investment into all of it. How that can be enhanced step by step and seamlessly, that would be the challenge we are working through. And upgrading existing software or adding modules that could make them AI capable as a plugin is more the approach. So there's so many types of collaboration environments that we have to take care of in product management, wearing different hats, and that is a lot of work that has to be done in order to make our product launches successful. We also try to keep it consistent, in terms of strategy, roadmap, and then this process of continuous product discovery never really ends. Assumptions continuously are stretched by improvements in technology, and also improvements that our customers begin to expect and start to learn and use. And overall, the more and more intelligent AI systems coming into play, and that kind of makes this a continuously moving track. So what, in terms of roadmaps, we prefer to have a dual track model with a discovery track and a delivery track. The discovery track is where the engineering is ahead of the game, building out the algorithms and products capable of future features, and we then have a lagging track that those features already that R&D has worked out gets into the delivery process. So ideas, discovery, plan, build, and measure is a continuously iterative development model which we use. So basically, all of this is now done in a continuous CI/CD with an Agile manifesto. So no more is it feasible to have a Agile or waterfall model, because the results and data are available really real time, and we make continuous changes to the software. So books that are, I allow are those like the 4 steps to the epiphany, the lean startup, jobs to be done, and what customers want. So there are many more books, and the waterfall model does not work for AI. That's something we have discovered. So pretty bit the entire organization has moved to a Agile delivery model. And so yeah, that's pretty bit what I had to share today, and I'm happy to have your comments, questions, and feedback. Thank you, everybody.